In this chapter, we're going to be discussing the first and second laws of thermodynamics, which really together, those are probably the two most important laws of thermodynamics. So really, this chapter is on thermodynamics. This first topic is maybe a little weird looking. It's about reversible processes. And what I mean by that is processes that may be reversible in time. And I'm not necessarily talking about time travel, but hopefully that seems at least a little bit weird when I say we're talking about processes that in forward direction of time and then also the backwards direction of time. In particular, a reversible process is one that makes sense both in the forward direction and the backwards direction of time. The definition on the key concept slide there is that a reversible process can be exactly reversed back to the initial state without any irreversible change to the environment. Now that might sound a little bit different than what I said a moment ago, where I said a reversible process is one that makes sense in both directions. How do you relate that to what this is saying? Well, as an example, I've drawn here on the whiteboard, let's say you've got a system that's in configuration A, and you consider the process of that system changing to configuration B. And then if you look at that same process, but simply reverse the direction, in other words, originally configuration A was initial and configuration B was final, but now we look at the same process with configuration B initial and configuration A final. So that's the reverse process. If that process looked at exactly that way makes sense, it's probably going to be a reversible process. But how do you reconcile that with this definition on the key concepts page is really the question that I posed a moment ago. And that may be a little bit more difficult to see because it's not really talking about time reversal as directly, I think. I mean, it does say can be exactly reversed back to the initial state. Well, maybe an analogy I can make is like, what if this is like a car engine? And configuration A represents the car engine in good working order. And then the car engine breaks, and that's configuration B, is now there's a broken car engine. And we know that it's possible, in many cases, to fix a broken car engine. I guess it depends on how badly broken it is, but let's assume that we can fix it, right? And then you could say like, well, okay, does that mean that the car engine braking is a reversible process? Because when I look at this picture and I look at these arrows, I would say, well, it makes sense. The arrow from A to B represents the car engine braking, and then the arrow from B to A represents the car engine being fixed. So if I can imagine that, it seems to work, right? It makes sense in both directions. But maybe I need to be more careful. It really should be the same process in both directions. And in that sense, if you said, well, does it really look the same going both ways? The answer is no. And one way of putting that into a definition that winds up being something that you can kind of use in looking at different situations and asking, so is this one reversible or not when you look at a process, is by considering the changes to the environment. When an engine is repaired, somebody has to do that, right? When an engine is broken, maybe somebody doesn't have to do that. I guess it depends. I mean, somebody could deliberately break an engine, right? But an engine can break on its own, and then a person comes in and repairs the engine. It usually doesn't do it by itself. And in reference to this definition, the person coming in and repairing the engine would actually represent an irreversible change to the environment. So in that sense, it's not really as simple as just saying, do these like two arrows exist? Is it possible to go from one state to another state and then come up with a process that takes you back to the original state? Because if it takes external work and external energy, which is what the repair person would have to do, right? They'd have to do work, they'd have to expend energy, do various things. But all of that is going to irreversibly change the environment. And so that rules that out as being a reversible process. In the examples, we're going to explore what is left. And if you ask like, well, how much is left? Are reversible processes commonplace in our reality? And I would answer and say not very much, but we'll be able to look at some and say, okay, either that's really close to being a reversible process, or at least we can come up with a situation where we would say theoretically it could be a reversible process. And all of this discussion is going to lay a foundation to the very end of this chapter, where we're going to look at entropy and the second law of thermodynamics.